My name is Richard Wolfson. With me is Chris Bell. I'm on Marshy School faculty. I teach physics. I also am adjunct faculty at MUM. A few months ago, I went to Chris Bell to ask about projects for Marshy School students, science projects. Chris started telling me about dirty electricity. I got so concerned, I felt we really needed to share this information. It's an issue we can really do something about. Today we're going to go through this dirty electricity, find it, and fix it. There'll be basically 4 sections. The first section will be, what is dirty electricity? Where does it come from? The second part will be, what is its health effects? What does the research show? Then the third part, how can dirty electricity be eliminated, with a demonstration? And then the last part is going to be homework for you. This whole presentation is on a website, and you can download it and check it out. Check out these references, the scientific references. I can't go into them in detail, but they're all here. So to download this presentation, go to MUMEcofair.org, then click on Speakers, Workshops, scroll down to Dirty Electricity, and it says Download Presentation here. So that's what we'll be doing in order. First, I'd like to acknowledge where I got this material from, these sources. Martin Graham on the list, Dr. Graham, is Professor Emeritus of Electrical Engineering and Computer Science at University of California at Berkeley. He's the one that invented the meter for measuring dirty electricity. He and Dave Stetzer, who's an electrical engineer and power consultant. This is really a major development. Martin Graham has a huge number of credentials. He has 100 peer-reviewed studies. Then the third person on the list here is Sam Milham, and he's a very distinguished epidemiologist, retired, and has 100 peer-reviewed studies as well. He's published this book on dirty electricity. It's his study at La Quinta Middle School in California that's going to be the main research and really the key, most important thing, I think. And I think it's really mind-blowing what he did, his research. We'll look at Magda Havis's, a few of her case studies. She's an associate professor at Trent University. So now we're starting, what is dirty electricity? Basically, it's distortion power lines. The clean white line that goes up and down is clean power. What that means is there's voltage coming out of the electrical outlet, and it's AC voltage, meaning it's alternating positive, negative, positive, negative, positive, negative. If it's doing that smoothly, that's clean power. That's clean electricity. But if it's sort of jumping up and down like jittering, that's dirty electricity. Dirty electricity is a jittering vibration that goes on top of the smooth vibration, so the electricity is no longer going smoothly up and down. Let's read it. A smooth sine wave indicates the AC current is smoothly alternating, and then this green thing is like it's smeared out because it's all over the place. The dirty electricity is the jagged curve that's blurred out, indicating the current has high frequency jitters as it moves. So I've got a following slide on that as well. This is an actual reading that's taken from a school in Wisconsin. The blue line there is the total electrical signal that's seen. It means it goes positive, negative. Positive is up, negative is down. It's smoothly going up and down, it looks like. But if you were to look under a microscope, you'd see it's not really smooth at all. There's a jitteriness that's behind the scenes that's smaller, and that's what the red line. So the red is the dirty electricity. One analogy that one of my teacher friends at Marshy School, Greg Holland, gave to help explain this, which I think is great, is let's suppose I had a slinky and I was holding one end and you were holding the other end. And I was going up and down in a really smooth motion, and the lady at the other end was jiggling it all over the place. So there'd be a jiggliness on top of the smooth sine waves. So I'd be creating the clean power, she'd be creating the dirty electricity by jiggling it randomly and wildly. So that's the difference. So there's this wild, random motion on top, and that's what the dirty electricity is. If I'm doing it maybe 60 times a second, which is the normal electricity, the Dirty electricity in this case is 12,000 times a second. So it's this huge jitteriness that's traveling on top of the regular power line. We'll see that's dangerous because it can impact the human body. Where does it fit into the electromagnetic spectrum? This is high frequency on the right, low frequency on the left, like treble and bass. On the right side is the highest frequency of the cosmic gamma rays, and then X-rays, and then ultraviolet. Then we see the visible light, which is one sort of segment of the electromagnetic spectrum. Going off to the left is microwaves, which is where cell phones and Wi-Fi. Then going down a little further is where the region of dirty electricity is. It's in the region of 2 kilohertz to 150 kilohertz. So this is the signals that are traveling on the wires in the room. We'll tell you in a minute what it's created by. What kind of problems? Research shows that radiation below 1 kilohertz, which includes the normal 60 cycle a second radiation coming from the power lines from clean power, is mainly harmless. So that doesn't penetrate the human body, it just dissipates on the skin. There's nothing to worry about. But frequencies above 1.7 kilohertz penetrate the physiology and can cause harm even at low voltage. So the high frequency oscillations coming from the walls, if there's dirty electricity, can come through the skin and cause damage, even if it's low voltage. Even if the lady down here is wiggling it only an inch up and down, if she's doing it at 10,000 cycles per second, that radiation correspondingly could penetrate the skin and cause problems. And we'll see what those are in a minute. The more jagged the waveform, the greater the frequency, the more potential for harm. Where does dirty electricity come from? There's two main sources. The first on the top is 21st century technology. And the idea is that the power comes in from the electrical outlet, it goes into the computer interacts with it and creates these dirty electricity signals that go back into the power line, which then go all around the room and through the building. Things that create dirty electricity: computers, dimmer switches, compact fluorescent bulbs, digital communications. Compact fluorescents are probably one of the worst. And that's probably what's causing the dirty electricity that's totally off the chart out here. We'll get into this in more detail in a minute. It's too bad because everyone thinks they're great because they save power, but I'll explain why they also create dirty electricity. And then the second source is our power lines are overloaded, which has resulted in deterioration of power quality, ground currents, which means electricity flowing in the ground, which then comes into our house and it creates dirty electricity. I'm not going to talk about the second one very much. This is an example of dirty electricity from a laptop PC. You may not be able to see it very well, but on the top we see these blue spikes. Instead of seeing a smooth sine wave, we see this spiky thing. This is the dirty electricity that's created within the PC, which is then sent back into the power lines, which travels all around your house and all around your room. And the closer you are to that computer, to the source where it's going into the power line, that's where the dirty electricity radiation would be the strongest. This spectrum analysis at the bottom is like separating out the components. If you're playing a note on the piano, you might say that's got 10% middle C and 20% C minor and 30% G or something. It's just got different components. In this case, it goes from low frequency to high. So on the far left is the 60 cycle per second clean power. Then we've got a harmonic at 180, then a harmonic at 300, then one at 420. So everything to the right of that first bar is high frequency signals that are created within the computer that are distortions. And the higher the frequency, mean the more signal to the right, the more cause for concern. Now I'll show you the Macintosh side. The blue line is the input, meaning that's the normal AC. The red is the dirty electricity that's generated within this PowerBook G4. These are, again, all the harmonics. This particular place where the arrow is, everything to the right of that is above 1.7 kilohertz, meaning that can enter our human body. So even though it looks like it's very low voltage, everything to the right is such high frequency that it can have harmful effects. If, for instance, something had a frequency of 60,000 cycles per second, even if it's a low voltage, it's 1,000 times more potent than something at 60 cycles per second. Because the more it vibrates, the more the energy and the more cause for concern. And now here's an example of a compact fluorescent. The compact fluorescents, I'm just reading this, create short, jagged pulses of current, which is in red. The blue is what's going into the compact fluorescent. The red is the pulses that come back out of the circuit, creating harmonics and distortions that flow back into the power lines. The compact fluorescents interrupt the current at least 20,000 times each second. So they're going on and off at least 20,000 times a second. The higher the frequency, the worse the effect. It's really difficult to even measure your dirty electricity, where it's coming from, if you've got all these compact fluorescent bulbs. We're working on LED bulbs, and LED bulbs will be better. So now, health effects, what does the research show? We're going to begin with La Quinta, California Middle School. This is what prompted me to do this presentation. This is a study that was published in the American Journal of Industrial Medicine in 2008. I'll read the right-hand side. In 2003, teachers at La Quinta Middle School expressed concern about high cancer rates among teachers. There were 18 cancers in 16 of 137 teachers that were employed from 1990 to 2003. There were 18 cancers in 16 of those teachers, and they said that was high. The local officials dismissed their concerns. An article went in the newspaper. Sam Milham, who's an epidemiologist, very respected, he saw this in the newspaper and he contacted the school, got some information. He confirmed it was very highly significant, it was unusual. He came in after hours with the assistance of teachers. The teacher he contacted, Gail Cohen, who'd had cancer and was recovering from it, she led him into the school after the school closed, took her around to the different rooms. He measured the dirty electricity, and he found very high levels of dirty electricity. These meters go up to 2,000. So after that, they go off limit, and there's no way to tell what they are. He found a lot of rooms in that school had levels that were off limits. I just put up so you can see Sam Milham's credentials, starting with assistant professor at Albany Medical College and on the American Board of Preventive Medicine and Washington State Public Health and 100 peer-reviewed scientific publications. So he's very well respected. And then the other author is Lloyd Morgan, who's an electrical engineer, and he helped him because he has the background in engineering, and he's also a cancer survivor. So let's look at the results in a little more detail. If we looked at all cancers at La Quinta Middle School, it came up to 18 total by 2006. That's the red line. The blue line is what would be expected. So blue is the expected, the red is what they actually had. So 3 times the expected cancer rates is what was actually observed at this school in overall cancers.